So we're going to take a quick look at the last topic of the unit, which is absolute value inequalities. Okay, so let's start off. Let's just think about a couple cases here and see if we can come up with a relationship. We're going to try. Go ahead and click and close. Put phones away. All that stuff. I think I can make this. This is a small class. You guys, we go through stuff pretty fast in here. I think we can get through this pretty quickly, and you'll get some time to work today. Honestly, I think we can. So to expedite this, let's just kind of quickly look at case one and case two. We want to see if we can come up with the graphs of these two absolute value inequalities. If the absolute value of x is greater than or equal to 7, Nathan, that's not, you're going to find that, not going to find your answer there. What would the graph potentially look like? Let's look for some values of x that would make that inequality work. Like if I were to put 7 would work, wouldn't it? Okay. What if I plug in 5? Would that work? That would not work. Okay, 5 fails. What about a number bigger than 7, like 8? Okay, that does work. Okay, how about something like -5? How about -7? Ooh, yeah, how come? Because it's an absolute value. Yeah, so -7, if I take the absolute value of that, becomes +7, which would work. How about -8? So we're seeing a trend then. Wouldn't it end up looking something like that, the graph, right? In order for the absolute value of a number to be greater than or equal to 7, that number either has to be big and positive or big and negative, right? Everybody buy that? Okay. And if I write that using interval notation, I can see that it's an or inequality, right? Values less than or equal to 7 or greater than 7. Okay. Okay, what about the bottom one? Different one. Absolute value of x is less than or equal to 4. Let's test some values. How about 5? Doesn't work. How about 4? 4 works. How about 3? It does work. Okay. How about -3? It does work, doesn't it? Because when we make it positive with absolute value, it's still less than 4. -4? Yep. -5? Okay. So we got another trend going on here that's a little different. This time we want the values of x that are going to be small positive or negative values, so that when they're made positive, they're still small, right? By the absolute value. Okay, everybody get that? So what does this mean? These two trends. What does this mean? Well, it means, as you might expect, that absolute value inequalities are going to split into compound regular inequalities. Because look at the two results we had. When we had an absolute value inequality in case one, we ended up with a compound inequality. Is that an and or an or compound inequality? That's an or compound inequality. If we had an absolute value of x being less than a number, we got an and compound inequality. That shouldn't be surprising though, right? Because wouldn't it make sense by extension if we think about what we did with absolute value equations? We isolated the absolute value and then we split the absolute value equation into two regular equations, right? Shouldn't we do the same thing with inequalities? We do, right? We're going to isolate the inequality or isolate the absolute value, and then we're going to split the absolute value inequality into either an or compound inequality, that counts as two, or two regular inequalities that make up an and inequality, compound inequality. Okay, and we just have to see the pattern. So there is a pattern, right? What did we see here? We saw that in the cases where the isolated absolute value, like the blue case, was less than a number, or less than or equal to, same diff. When it's less than a number, then the absolute value inequality splits into an and compound inequality. And it works like this. Okay? Whatever's inside, so there's my isolated absolute value being less than some number. Whatever's inside is going to be greater than the negative and less than the positive. Okay? Right? So that's what we get when the isolated absolute value is less than a number. Okay, what happens when the isolated absolute value is greater than a number? Then we do the other kind, right? If the isolated absolute value is greater than a number, it splits into an or compound inequality, where what's inside is greater than the positive or what's inside is less than the negative. Okay? Give me thumbs on that. Does that make sense? Or 1 to 5, you take your pick. Okay? And then our strategy is going to parallel what we did with equations. Same stuff. We're going to isolate the absolute value expression first. Then we're going to create our two cases and just ignore all that stuff. We're going to create our two cases, which means we're going to split the absolute value inequality into a compound inequality. We're going to solve the compound inequality. And then usually we're going to graph our solutions and write the answer in interval notation. Okay? To make this thing a little bit easier, to this process a little bit easier, I'm going to force you guys to memorize these patterns. So come up and grab, you're going to grab potentially two things. So I have a flashcard cutout sheet. It's only got 3 questions on it, but if you cut along these lines, you're going to get a question on one side and the answer on the other. Like, for example, the question is going to say something like split the absolute value of u is greater than a into a regular compound inequality. And then on the back side, it says u is greater than a or u is less than negative a. Okay, so these are ready-made flashcards. If you want to use those, that's fine. If you'd rather just make your own, there are index cards here, but take your pick, one or the other, or both if you want to. And then what I would recommend you do with these, we got tests coming up, so the flashcards are really just to, get you ready for the test, right? As we go through the units and we make more of these flashcards, just throw them in a Ziploc bag or something. Maybe like 1 Ziploc per unit, and then you got them when you need them. Okay, so first flashcard is the absolute value of u is equal to a. So this is one we've been doing for a while. How does that split up? U is what? U just stands for, and remember, U is just what's inside the absolute values. A is the number that's outside. So how does that split? If the absolute value of U equals A, then U equals A, or no, it's equals negative A. Yeah, you see the pattern? So what's inside either equals the positive or what's inside equals the negative. Okay, there's the pattern that we learned in section 1.4. Okay, here's our new patterns. So if the isolated absolute value, the absolute value of U is less than A, is this going to convert into an and or an or? How do you know? I'll tell you what, there is a way to know. There's a slick way to remember this. If we go back, where is this? Well, I don't see it there, but here's how we could do it. I'll just talk you through it. So imagine that inequality symbol that's in the middle. If I rotate that thing 90 degrees clockwise, so just like the hands on a clock, imagine that the hands on a clock are going to push that thing 90 degrees. What kind of symbol does that turn into? It turns into an and, doesn't it? Right? So if you rotate it 90 degrees clockwise, that turns into an and, which reminds you that this is an and inequality. What's inside the absolute values is going to be in the middle. Ands are the 3-part inequalities. What's inside the absolute values goes in the middle, being greater than the negative and less than the positive. And then the same rule applies here. If I take this greater than symbol and I rotate that thing 90 degrees clockwise, it turns into an or, doesn't it? So that reminds us that it's an or statement. So what's inside the absolute values is greater than the positive, or what's inside is less than the negative. So make a flashcard for each of those if you're making your own. The absolute value expression goes on one side, and the pattern with regular equations or compound inequalities goes on the other side. Okay, take a second and do that. Done? Yours is already done, isn't it? Okay, so I'll put these back up at the end if you need to finish your flashcards. Let's look at a couple sample problems here. So how about this one? We got to solve this absolute value inequality. What's step one of solving an absolute value equation or inequality? What do we always want to do first here? Isolate the absolute value. Okay, what are the two steps to do that? So say it again. Add one, then divide by two. Everybody agree? Okay, so we add one. So those guys cancel. That gives us 2 times the absolute value of 3x plus 9 is less than 6. You told me to divide by 2. Okay, that's good. And then that gives us, when we do that, we get the absolute value of 3x plus 9 is less than 3. Agreed? Okay, so we isolated the absolute value. What's next? Got to split it into a compound inequality. Ava, is this going to be an and or an or? Okay, so here's the inequality. If I rotate it 90 degrees, so it's an and, isn't it? Yeah. So it's and. So the pattern is what's in the middle is greater than the negative and less than the positive. Okay. Leah, what's that give us if I apply that property? So what's that give us? If I use I've got my isolated absolute value. Here's the pattern I'm going to use. It's an and pattern when I split this. What's it split into then? How am I going to write that? So this is like my u, right? Whatever's inside is the u. Okay, -3 goes on the left, doesn't it? Okay. What goes in the middle? Okay. Whatever's inside it, right? So 3x plus 9. We've gotten rid of the absolute value. And it's going to be greater than -3 and less than 3. Okay. Everybody see how we get that? Right? That's our pattern. That's our splitting pattern. What's inside goes in the middle. The negative number goes on the left. Positive number goes on the right. And it's an and inequality. Okay, Ellie, what's next? Solve. Okay, so what would the two steps be to solve for x there, to isolate x? Subtract 9. There you go. So that's gone. That's going to give us -12 3x and -6. We divide everything through by +3. So I don't have to flip anything, do I? I'm dividing by a positive. And we end up with -4x and -2. So x is greater than -4 and less than -2. If I graph that on a number line, doesn't that just look like that? Everybody good? Okay, give me 1 to 5. Okay. All right. Let's try another one. Carson, what am I doing here? So what's the first step when we're solving any I almost gave it away, any absolute value equation or inequality? What do we do first? If I go back here, let's go back a little bit. Right. What do we always do first? Yeah, maybe does that make sense? Okay, isolate the absolute value. Okay. So what's the one step I need to isolate the absolute value then? What do I have to do to what's the one thing I have to do to isolate that absolute value? I got to get it by itself on one side of the inequality. So what do I got to do? Here's the absolute value. What do I have to do to get that by itself? I got to add 6. Yeah, right? Because 6 is being subtracted. I have to undo subtracting 6. So we're going to add 6. Okay, and that's going to give us our absolute value is greater than 24. Okay, good. We isolated the absolute value. Julia, what's next? After we isolate the absolute value, what do we do? Got to split it up. Is this going to be an and or an or? It is or, right? Good. Hey, all right, good. And we get that because if we take this inequality symbol, we rotate it clockwise 90 degrees, it becomes an or symbol, doesn't it? Okay. So here's our or pattern that you're going to memorize with your flashcards, right? If the absolute value of u is greater than a, either u is greater than a or u is less than negative a. Okay, so let's write all that. So inside is the u stuff. Let's make that green. Kind of keep track. We'll color code this. Keep track of everything. That's u, and this is a. Okay, so Josie? What do I get out of this? And what does that become when I split it? Say it that way. Okay, is less than negative 24. Okay. Or what? Is greater than positive 24. Okay. And does it make any difference which of those two statements you say first? Doesn't make any difference. Ors are interchangeable. Okay. Okay, good. So we isolated the absolute value. We split it into compound inequality. Last step. What do we got going? Last step. Nadia, what do we do here? Yes, now we've got the two inequalities. We have to solve them, right? Let's take this one over here. What do I have to do to solve for x? What are the two steps? Okay, got to subtract 21. Good. And then divide by, well, negative 3. Okay, good. So there's my two steps. Subtract 21, divide by negative 3. All right, let's do that. So minus 21. Those guys cancel. So I get negative 3x is less than negative 45. Okay, you told me to divide by negative 3. Good. Okay, I divided by a negative. So what do I have to do? I got to flip that inequality, don't I? So I get x is greater than 15. There you go. So x is greater than 15. Or what about the other side? If we do the same stuff, right? Same step, subtract 21, and I get negative 3x is greater than 3. Divide both sides by negative 3. What do I get? X is less than. Good, I got to flip it, don't I? Because I'm dividing by a negative, I have to flip it. X is less than negative 1. So there's my final answer. X is greater than 15 or X is less than -1. If I graph that, what does the yellow part look like in my graph? What's the yellow part look like there, Whitney? X is less than -1. Say it again. It's an or statement, right? Okay, but so we have to graph them separately. We're graphing the X is less than -1 part. What's that look like? Just a graph of that. What kind of endpoint am I going to use? If it's just less than. Open, good. Okay, and which way am I shading? If it's less than -1, less than means I go left, right? So I'm going to go that way. That makes sense? There's all the values less than -1. If I graph the blue, what's that going to look like? Open circle to the right of 15. Okay, good. And that allows me to pretty easily turn this into interval notation. Once I've got the graph, interval notation is pretty easy. Nathan, how do I do interval notation for the yellow graph? Okay, but it's an open endpoint. So it's a parenthesis, okay. Negative infinity, good, because it's going negative direction. Okay, comma. Okay, parenthesis or bracket? Parenthesis, good. Okay. And how do I do or with interval notation? Good, that's my U. And then the blue, how do I say greater than 15? Parenthesis. Go ahead, everybody can pitch in. 15, comma, infinity, parenthesis, good. Okay. Okay, good. Give me 1 to 5. How we doing? Okay. Okay, we can skip the practice. Let's just go right to a couple quick examples and I'll turn you loose. So let's just walk through this one together. There's just one part of this I want to remind you about. So it's already isolated. The absolute value is already isolated. So vote with your thumbs. Thumbs up is and, thumbs down is or. Which one is that? Thumbs up is and, thumbs down is or. What are we splitting into? Good. It's and. Excellent. So we have an and pattern. Okay, so then whatever's inside is going to be greater than the negative and less than or equal to the positive. So wouldn't that just look like that? Okay, everybody good? That's how it splits. Okay, we're going to solve. So there's 2 steps to solving would just be subtracting 7 and then dividing by -4. If I subtract 7, I'm just going to get that, right? Subtract 7 from each part. Okay, divide by -4. What do I have to remember to do? Got to flip the signs. Negative over negative is positive, and 34 over 4 reduces to 17 over 2. The -4 goes away from the middle. 20 divided by -4 is -5. Okay, are we done? What else do we have to do? Okay, we'll graph it, but is that the right way to write that answer? What do we need to do? Well, I could, but the fraction's good. But yeah, we got to flip it around because it's going backwards, right? An and inequality has to go from smaller to bigger like a number line so it matches the interval. This one doesn't. It's going backwards. So I just have to take that whole thing and flip it around so it looks like that. Agreed? Okay. All right. How about this one? I got to isolate the absolute value. What are the 2 steps to isolate the absolute value, everybody? What are they going to be? Carson, I got to isolate that absolute value. What do I have to do? Oh, yeah, you got this. So look what's being done to it. The absolute value, it looks like it's 1 is being subtracted from it, right? And it's being multiplied by -4. So I have to undo that stuff. I got to be able to cancel those out. So what do I have to do first? Okay, but I have to I'm doing inverse operation, so I have to add or subtract first, then multiply or divide, right? So I add 1 to both sides, right? I got to get rid of that. I cancel it out. There's one cancellation step. Add 1 to both sides. Okay, good. Done. Now what? Oh, you got this. How do you undo? The absolute value is not isolated because it's being multiplied by -4. How do you undo that? Divide by -4. There you go, which means we have to flip the sign, right? Okay, good. It looks complicated isolating up here, but just treat that absolute value as just one big variable, right? That you're just trying to get by itself, just like you would if you were solving an equation, but that whole thing is just acts like the variable, okay? So now we've got an isolated absolute value. What's our pattern here? What's our pattern? Whitney, is that going to be an and or an or? It's an or, good. The inequality turns into a V, so it's an or if I rotate it 90 degrees clockwise. So we got that pattern. What's inside is greater than the positive, or what's inside is less than or equal to the negative in either order, right? Doesn't matter which one you say first. Okay, are we good with that step? Give me thumbs on that step. How are we doing? We good with that step? Okay, all right. And then last step, subtract 9 from everything, and we're done. Okay? All right, so I have just a little challenge for you. This is not a math thing. This is kind of a puzzler challenge problem. Okay, this is for Monday. It's not required. But if you get this correct,